Okay, for each of the following pair of lines, we need to find the angle theta between the two lines where theta is between 0 and 90 degrees. So for this, right, actually it's quite easy question, right? So the main category, the topic that they are looking at is finding angle between two lines. So if you recall what I've learned in our lecture questions, that you want to find angle between two lines. So for example, line 1, let's say this is A1 plus lambda M1, right? And line 2 is supposed to have defined as a position vector A2 plus mu of M2. Like, you cannot use lambda anymore, right? Right, then the angle between these two lines, line 1 and line 2, or we always define it as the acute angle, right? So it's the angle over here. So very easy. What we do is we just find it accordingly by taking it as the cosine by using the direction vector between the two lines. So we acknowledge that one direction vector is M1, the other direction vector is M2, and then the angle between these two lines is just cos theta equals to mod of M1, M2 over modulus of M1, M2. Right, so we always assume theta to be acute unless otherwise stated. Alright, okay, so next, what do? Very easy, we just need to look at the question. Okay, so now if we look at this, this is in Cartesian form, right? So this is in Cartesian form for the equation. Over here, okay, this one is quite readily, this is actually in our vector form. It's a vector equation, right? Okay, so in order for us to really find the direction vector of both lines, we need to compare both equations of the lines in vector form, right? So we need to find the vector equation. Okay, so first one, part A. So for part A, right? Okay, so for part A, alright, for the first line, the equation L1, right, is R equals to 6, 4, 0, separating out all the position vectors, plus lambda, negative 1, 0 and 1, right? And line 2, right, what we can do is we know that it looks like this from x minus 5 over 2 equals to y over 2 minus 1 equals to negative z, right? So what we do is from here, we try to swap this into the vector form, right? So easily you can have just solving this 2 lambda equals to x minus 5, x equals to 5 plus 2 lambda, okay? Lambda plus 1 equals to y over 2, so 2 lambda plus 2 equals to y. 1 second, and then next one, lambda is just equals to negative z, therefore z is equals to negative lambda. Alright, so from these three, you can actually quickly form your equation. Your vector equation is x equals to 5 plus 2 lambda, so 2 lambda. Y is equals to 2 plus, you just let me erase this, right? Plus 2 lambda as well, so it's 2 lambda. And you have z is just equals to 0 minus 1 lambda, right? So with that, you can actually quickly form the vector equation for line 2, alright? And instead of using lambda, perhaps I should use mu instead, since lambda is already used, alright? So maybe let me change this to mu, and mu, right? So this is a mistake I will make, so we might make it really hard. So just take note that we try to avoid using the same variable, but the same scalar. Then after that, okay, so line 2, so quickly we can now find we recognize, oh, this is our M1, this is our M2, alright? So very quickly, the angle between the two vectors, cos theta, it just equals to the negative 1, 0, 1, dot product with 2, 2, negative 1, okay? And mod square root 2, square root 9, Okay, so this will give you eventually the modulus of negative 3 over 3 square root 2 equals to 1 over square root 2. Alright, since cos theta equals 1 over square root 2, actually it's just a special angle, right? Theta is just equals to 45 degrees. Alright, and we are done for part A. Similarly for part B, alright, 2, 3, negative 1, 2, 3, negative 1. Okay, and second line is 4, 1, negative 1, 2, 1, negative 2. So very quickly, let's just write our equation out for part B neatly. Okay, so for part B, L1 R, right, is equals to 2, 3, negative 1 plus lambda 2, 3, negative 1. Okay, and L2 is equals to R equals to 4, 1, negative 1 plus mu of 2, 1, negative 1. Okay, where mu is a real number. Okay, and with that, right? Okay, with that, alright, what we're going to do is now very simple. We can see that this is our M1, this is our M2, right? This is the M1 that we'll use in the formula. This is the M2 that we use in the formula. So quickly, cos theta it just equals to the M1, M2, remember, this is from our formula, and magnitude of M1, magnitude of M2. Okay, so this is just 2, 3, negative 1, dot product with 2, 1, negative 1 over, so if we have 2, 3, negative 1, magnitude is square root 14, 2, 1, negative 1, the magnitude is square root 9, right, the magnitude of this, and then we just end up with almost 4 plus 3 plus 2 over square root 14 square root 9. Alright, and this means that theta should give you 36.7 degrees. Okay, right, so next question 8C. Alright, first what we have our R, L, right, to be equals to 111 plus lambda of 1, negative 1, 1, where lambda is a real number, and second portion we have line 2, where our R is just equals to mu of negative 1, 1, negative 1, where mu is also a real number. And then from here, all you do is now very quickly we just take the cosine theta, use the formula again. But even before you do it, just notice that this is the M1, right, and this is M2, right? So as you write the formula, what do you see? What do you notice about them, right? So they are actually the same, right? So actually the same, right? So what does it mean? It means that if M1 and M2 are the same, they have the same differential vector. It means what? It means that actually M1 equals M2, right? This implies what? This implies that L1 is parallel. L1 is parallel to line 2. Right, so if they are parallel, what does it say about the angle, say the angle between them? It just means that, very simply, if they are parallel, then angle between line 1 and line 2 is what? What's the angle between line 1 and line 2? It's just equals to 0.